Hi everyone, my name is Yaofeng. Today I will present my project on large language model in system reliability. In simple terms, this project asks one question: how are LLMs being studied and used to support reliable software systems? I did not focus one single tool or one single paper. Instead, I look at the research field as a whole. The main number are shown on this slide. I used 5,099 record for the broad science map, and I used 3,469 scope record for the later modeling. The Bertolpi model finds 38 things, and the mean path analyze finds 3 citation path. This number get a bioscale of the project. This slide explains why the topic method LLMs are now being used for many software tests. For example, they can help read logs, generate tests, explain error, or suggest code reply. This is useful, but there is also a risk. So software systems are used in important areas such as healthcare, finance, transport, and public service. If an LLM gives a wrong answer in this setting, the problem may not stay inside the computer, it may affect real users. So the question is not only whether LLMs are powerful, the question is whether they can be used safely and responsibility in reliability related work. The problem I found is that the research field is growing quickly, but it is spread across many different areas. That is why this project map the field. The aim of my project is to understand how research on LLMs and system reliability has developed. I divide this aim into 3 objectives. The first objective is to understand publication pattern and important source. This helps answer questions like who is publishing, what sources are important, and what topic appear in the literature. The second objective is to identify major research themes. For this part, I use Bertolpi to group paper based on their titles and abstract. The third objective is to find a stronger citation path. This helps show which paper are most clearly connected through citations. So the project moved from a broad view of the field to a more focused view of the key research path. This slide shows the data source. I use Scope and Web of Science, but they have different roles. Scope was the main data set for the modeling part. It has 3,469 records. I use it because it includes useful information such as title, abstract, keyword, author, citation, referencing, and DOI information. Web of Science was used as a secondary sources. It had 1,630 record. Together, Scope and Web of Science give 5,099 record for the world's views science map. I keep the dataset separate because different methods need different data. The combined data was useful for a broad map of the field. The scope data was easier to clean and follow through Bertolpi and mean path analysis. This made the data path clearly and easier to explain. And then we can find this picture, the whole workflow of the project. At the top, I start with the research aim and objectives. Then I collect data and development the research strategy. After that, I clean and prepare the data set. The main analysis stage has 3 parts. First, I use both viewer for science mapping. Second, I use Bertolpi for topic modeling. Third, I use main path analyzing for citation path. The last stage was result evaluation and citation review and critical review. This final stage was important because software tools can produce graph and constructor, but those outputs are not automatically corrected. I still need to check what they mean and whether they match the actual papers. This slide shows the broad science map for VOS viewer. The first map is the efforts map. It shows that the field is not controlled by one single effort group. Instead, research activity is spread across different groups. The second map is the keyword map. This map shows that the topic connects several areas, including LLM, software testing, security, diagnosing, privacy, and maintenance. The third map is the site referencing map. It shows that this field built on both AI research and software engineering research. The key point for this slide is that LLM's reliability research is broad and interdisciplinary. This result also support the need for the later analysis because a broad field needs a clear structure. This slide explains why I did not choose K-mean as the final model. I test K-mean first because it is common constructing methods. The elbow method is the method and silhouette score was used to check possible control number. However, when I compare the result, K-mean gave only two board topics. This was not enough for my project. The topic of LLM in system reliability, including many errors such as software testing, log analysis, uh, pro program require fault diagnosing, and trustworthiness. Two topic was too general to explain this field, so I collect HDB scan-based per topic model instead. HDB scan was better because it could find more detail groups. It also allowed unclear paper to become outliers instead of forcing every paper into a topic. This slide shows the final topic result. The final model identifies 38 topic groups. It also assigned about 24.8% of document as outliers. This means those documents did not fit clearly into stable topic group. In this project, I do not treat the outline as a field. The field is broad, and some papers are difficult to place into one clear group. The topic size chart show that some topics are much large than others. The intertopic distance maps show that topics are spread across different areas, not just one compared group. The main thing I including hallucination and trustworthiness log a modeling decision maintains knowledge software testing and require reliability analysis and fault diagnostic. So but topic helps show the internal structure of field in more detail. This slide shows the simplified min-pass result. The full citation map was too confusing to show clearly, so I used this simplified version with this free path. The free paths start from different paper, but they all pass through one at all 2024 and the end with one at all 2023. This means that these two papers are important connecting point in the citation path. The result also show that the strongest citation path is mainly about software testing, generation, and automatic program reply. This is lower than the full bird topic result. Bird topic show many things, but the mean citation pair is most clearly development in testing and reply. This control is one of the main findings of my project. This slide summarized at the citation critical review of the key papers. The purpose of this day was to check the meaning of the automatic result. The key paper showed a movement from large language model-based software testing to more controlled reliability support. For example, Wang et al. 2024 provide a broad view of large language model software testing. Wang et al. 2023 focused on virtual program reply. This is important because the game model extract information so the result is more controlled than simple promoting. Other paper focus on test plan, simple thing, is execution and test case generation. The main lesson is that stronger studies usually do not rely on promoting alone. They combine LLMs with simple methods, standard or human checking. This slide connect the project to reasonable research. The first question is uh, hallucination. Large language model can sound confident even when they are wrong. In system reliability, this can be dangerous. The the second issue is privacy loss, and incident report may include system or user information. The third issue is accountability. If LLM suggestion lead to a bad decision, people still need to know who check it and who is respond. The fourth issue is human oversight. LLM's output should be checked before they are used in reliability critical work. So my view is simple. LLMs can support reliability decision, but they should not replace human judgment. Then this slide get overall discussion. The field is born, but not eventually development. Some areas are more mature. Software testing, test generation, and automatic program reply are more connected through citations. Other areas are still emerging or more focused. This include log normal decisions, maintain knowledge, reliability analysis, and fault diagnosing. The project also have limit. The result depend on the database, search term, topic model setting, and DOI matching. So the finding should not be treated as the final answer for the whole field. They show a structured view of the dataset I collect. Future work, future work could use more data source, compare the compare the decoupled dataset, test order topic model, and evaluate LLM tools in view of optional environment. So for the last one, I want to highlight these three takeaways. First, LLM's reliability research is for an interdisciplinary role, but it is not eventually development. Second, the clearing citation path is currently in software testing and automatic program reply. Third, practical use still need va- validation, domain control, and human our life. For me, the most important message is that LLMs should be treated as support tools. They can help engineering, but their output still need to be checked. This is especially important in reliability relay work because the cost of the raw answer can be high. So thank you for your listen.